All right, today we're going to dive into a case study that really gets to the heart of a huge challenge in modern mining: the constant, expensive battle against wear and tear in slurry transport systems. We'll look at how one mine completely turned the tables on this problem. So let's get right into it. But first, I want you to think about this for a second. What is the true cost of pipe failure at your site? Seriously, it's not just the price of a new section of pipe, is it? It's the lost production from downtime. It's the endless hours your maintenance crews spend patching things up. And, most importantly, it's about the safety risks you're introducing every single time a system fails. If you're an engineer dealing with hydraulic backfill, this whole thing is a daily grind. Moving slurry, it's just a constant battle against abrasion. That stuff is incredibly unforgiving, and it will always find the weakest link in your entire system. And that brings us to a real-world example: the Buriticá Mine down in Colombia. The operator there, Zijin Continental Gold, was facing this exact problem, a classic, high-stakes headache with their hydraulic backfill operation. So what was going on? Well, their existing system used traditional HDPE pipes, and frankly, it just wasn't cutting it. They were seeing massive internal wear from the abrasive slurry, no surprise there, but they also had constant leaks popping up at the pipe connections. On top of that, imagine trying to install rigid pipes in these cramped, dark underground spaces. It was a nightmare. And of course, on any sloped section, the wear was even worse. It was a recipe for disaster. And let's be clear, these weren't just little annoyances. These failures meant real, expensive downtime. It meant a maintenance team that was always putting out fires instead of doing preventative work. And it created some pretty significant safety risks for the whole operation. They didn't just want a better solution, they absolutely needed one. So how do you fix a problem like this? You don't just find a slightly better pipe, you find an engineered solution, something designed from the ground up for these exact conditions. And that's where Pexgol PEXA comes into the picture. Okay, so what exactly is Pexgol? Well, it's not your standard polyethylene. This is cross-linked polyethylene, or PEXA. That cross-linking process creates this incredible molecular structure that gives the material just next-level durability and abrasion resistance. It's literally engineered for the absolute toughest jobs out there. And when you put it side by side with the old stuff, the difference is just night and day. On one side, you've got HDPE, which is constantly getting chewed up from the inside out and needs replacement all the time. On the other, Pexgol's high abrasion resistance means a way longer lifespan. And installation? Forget about wrestling with heavy, rigid pipes. Pexgol comes in these long, continuous coils that just completely change the game. So that all sounds great in theory, right? But the real test is how it performs out in the field, in a demanding place like the Buriticá Mine. So let's get to the good part. Let's look at the actual results. First, let's just be clear about the working conditions, because this is where the rubber meets the road. We're talking about hydraulic backfill, moving a slurry made of sand, water, and cement, with a 70% solids content. Think about that. That's basically liquid sandpaper, running at a pressure of 8 bar. This is an incredibly hostile environment for any piece of equipment. And the installation? It was amazingly efficient. The whole process took just 2 shifts. The crew literally uncoiled the pipe right there on the surface, fed the continuous length down a ventilation shaft, put in a few supports, and then made the final connections with flanged couplings. That was it. Simple. So, after installation, the moment of truth. Remember all those leaks that plagued the old system? With Pexgol, how many were there? 0. A big, fat 0. Those long, seamless runs of pipe just completely eliminated the points of failure. And what about the installation headaches? Well, because the Pexgol pipe is so inherently rigid and strong, they only needed to place supports every 3 meters on the horizontal runs, and in the vertical drop, none at all. Think about the savings in materials and labor right there. It was a huge win. So let's just tick off the final scorecard here. The core problems, the wear and the leaks, they were completely eliminated. The installation was incredibly fast and efficient. The pipe's flexibility meant it adapted perfectly to the mine's layout. And the bottom line? Maintenance costs plummeted, and the entire operation became a whole lot safer. Okay, so that's a great story for one mine. But how does this case study actually translate into a real advantage for your projects? Let's talk about how you can replicate these kinds of results. The success they saw at Buriticá wasn't a fluke. It was the direct result of applying the right engineered material to a very specific, very tough problem. Pexgol has proven, time and again, that it's the solution for these kinds of slurry challenges. And this is the key point I really want you to take away from this. The incredible performance they saw in Colombia, that's not unique to that one mine. That exact same combination of durability, safety, and efficiency can be engineered to meet the specific needs and challenges of your site. For all you engineers and project managers out there who are ready to dig into the nitty-gritty, the next step is getting into the technical specs. You can get your hands on a full engineering guide and a complete BIM and CAD library to see exactly how Pexgol would fit into your designs, making the whole process that much smoother. So I'll leave you with one final question to think about. When you look at your own slurry transport system, do you see a strategic asset, something that reliably helps you hit your production targets? Or do you see a recurring liability, a constant drain on time, money, and a source of risk? Because the technology to change that whole equation is out there, and now you've seen what it can do.